Welcome to Brain Vision.
So in this question, we are given a series RCL circuit, and the capacitance of the capacitor is 6.6 microfarad. The inductance of the inductor is 7.2 millihenry, and the peak voltage V peak is equal to 320 volt, and the frequency is 1.5 into 10 raised to power 3 hertz. Now we have to find out that what is the instantaneous. So we have to find the instantaneous voltage across conductor and inductor at T is equal to 1.20 into 10 raised to power minus 4 second. The next thing that we need to find out is the instantaneous current at T is equal to 1.20 into 10 raised to power minus 4 second. Now, first of all, look at part A, that is the instantaneous voltage. Instantaneous voltage. So, for that, we are going to use the phasor method. So, okay. First of all, suppose that the peak value of current in this circuit is I naught, and the peak value of voltage in this circuit is V naught, that is equal to 320 volt. Now what do we need to do? The next step is that we need to find out the reactance of inductor. So we need to find the reactance of inductor, that is inductive reactance. XL is equal to 2 pi FL. Substitute the values and you will get 67.85 ohm. The next thing that we need to find is the capacitive reactance. So that is XC. We know the formula, 2 pi FC. Substitute the values and you will get 16.07 ohm. Now if you compare these two values, you will get to know that XL is greater than XC, that is inductive reactance is greater than capacitive reactance. The next thing that we need to find out is the peak voltage across the inductor. So we get VL is equal to I naught times XL. So that becomes VL is equal to 67.85 I naught. The next thing that we need to find out is the peak voltage across the conductor, and that is Vc equal to I naught times Xc. So when you substitute the values, you get 16.07 I naught. Now if you compare this and this equation, you will get to know that VL is also greater than Vc, just as XL was greater than Xc. So now you have to suppose that the instantaneous values of the voltage and current are represented by their phasors on the x-axis. So you will get something like this. This is your positive y-axis, this is negative y-axis, this is negative x-axis, and this is positive y-axis. So we are using the phasor method and we are supposing that the instantaneous values of current and voltages are represented by their phasors on the y-axis. So it means that this is our V naught, that is the peak value of voltage across this circuit, and this is the voltage across the capacitor, and this whole voltage that is across this x-axis is the voltage across the inductor. So now if we rotate the phasor, so at a speed of rotate the phasor at a speed of 2 pi f after t is equal to 1.20 into 10 raised to power minus 4 second, we'll get that the phasor voltage V naught makes angle is equal to 2 pi ft with x-axis. Okay, so in order to understand this, let's look at this figure. So over here we have rotated it. We rotated our phasor voltages. Okay, so this is V naught, and it is making an angle phi that we just wrote, that is equal to 2 pi ft, and over here we have our instantaneous current, and this is what this phasor representation looks like. So next we need to find out the net voltage across L and C. So Vt is equal to V naught sine angle, so that is V naught sine 2 pi ft. Substitute the values, that is 32 sine 2 pi times 1.5 into 10 raised to power 3 times 1.2 into 10 raised to power minus 4. So we get that the net voltage across inductor and conductor is equal to 3.3 into 10 raised to power minus 3 volt. Now the next thing that we need to find out is the instantaneous current. So for that we need to find out the total impedance, that is Z. So Z square is equal to the impedance, the reactance of R plus the reactance of inductor and negative the reactance of the conductor whole square. So this part is equal to 0. So we are left with Z square is equal to parenthesis minus XL minus XC whole square, taking square root, so Z is equal to XL minus XC. Substitute the values and you get that 51.78. So the impedance is equal to 51.78 ohm. Now we need to find out the peak value of current, that is I naught. So how will we find out that? So I naught is equal to V naught divided by the impedance. V naught is equal to 32. Z is 51.78. So calculate it and we get 0.617 ampere. Now, the next thing that we need to find out is the instantaneous current. And this instantaneous current will be is equal to the vertical component of current that we just found. So it means that the instantaneous current becomes negative current I naught times cos angle, that is equal to I naught cos 2 pi f t. So when we substitute the values, we get negative 0.617 ampere. So this is your answer.